Lightning, why don't you introduce us to your challenge?
So, sorry for the delay. I was actually still working because I got confused about the time zone difference. b3s23 is a challenge from Quals at DefCon 2016 that is possible to access remotely. The description itself should already give you a hint as to what type of challenge it is or what it's actually doing in the challenge. So if you start working on it, my recommendation is give it some data and see what's kicking back at you. And you might try Googling the name. The name may actually give you an idea as to what the description is trying to reference. It should give you some hints as to what some of the functions are doing in the code.
All right, so we will proceed as usual and start working on it. Splits ourselves throughout the virtual tables. Lightning will go around the tables as she sees fit, chatting with you or answering your questions. And later on, we will rejoin for hints or maybe a little bit of progress over the evening, and we will wrap things up with a small interview with Lightning. And afterwards, we will have some digital games, probably, as we been doing for the last couple of months. So thank you, Lightning, and thanks, everyone. Have fun.
So the challenge is Conway's Game of Life. If you actually look up the rules about it, you'll see that there is a cell setup that affects which cells are alive and dead. A good question is, what is the grid size of the game that the code is working on? And how many iterations is it modifying the system before it actually tries to run shellcode on the result? Enjoy the hint. So if you've not figured it out yet, trying to brute force this is not possible, as I mentioned before. Look up still life. Still life allows you to guarantee that nothing changes, regardless of how many iterations you go through. So let's go ahead and see how to get this solved. I already have the challenge opened up in Kahidra. And I'm first going to bypass the alarms so that we can poke around the debugger without the application being killed on us. Add instruction. Jump. I want to jump down to this call. And the reason I'm doing a patch up here is patching the actual instruction itself can actually cause trouble with relocations and other info in the library or in the application. Now if I go and have to first select. Now there's a script I mentioned earlier called save patch. This actually allows you to save a modified binary out. And we're going to save to. Oops. Mod. It runs, there's no problem. So let me set up on the local port to run. Now anytime I connect to the local port, we have our actual binary. If you were looking at the binary itself, you discover that it receives a bunch of coordinates in XY, and then once you send anything else to run, and then it actually kicks out a bunch of permutate or a bunch of generations to you, and then it actually jumps to the buffer itself. We actually want to see what the registers are when it's trying to execute code. This actually makes it easier to figure out what the shell code should be. Because trying to embed a full large chunk of shellcode to call binsh into this is not going to be easy. However, if we can embed like read or a syscall into read, this actually becomes a lot easier. So create connection to where I pass in on the command line, my port, receive the header line. We'll give a coordinate to work with. Now I want to know what it's actually doing before it actually goes and runs the buffer. I want to be able to open this up in GDB and attach to the actual running process. So I'm actually going to put a delay in here before I send the actual final command to have it continue running. Then save. So I should be able to run this. So I need to know what the memory is. pgraph for b3s23 mod maps. It equals. pgraph's very handy if you only have one process running with the same name. Whoops. I had to reboot the VM. I forgot to turn off the ptrace. Get my area. So the binary itself is at this location starting. We need to know the offset to go to. So we call into the main function, get down to where it executes code. That's on 11170. Behavior loads by default at 10,000 though. So we don't need the 1170. If I continue this, and then I send data, I'm at my call. So we know the buffer is at F7, F5, 6000. We actually see this in EBX also. So we're going to copy some of these registers. So I need to generate some shellcode, but I don't know what shellcode I actually need. So we know EAX to be whatever it is for read. EBX is going to be 0 for standard in. ECX must be the buffer. And EBX is going to be our length. You can look up the actual syscall table for Linux. In 32-bit, read's actually 3. So simple shellcode for doing this would be moviex3, moviex0, whoops, move ECX to EBX buffer, move EBX0, move EDX, some size, int 80. The likelihood of this actually working for our code itself, though, is not very high. We actually need to know what we actually generate. And this gets into the still life itself. So let's actually have a way to generate some shellcode and see if it is valid still life options. One of the things when looking through the Conway's Game of Life, if we have 3 bits in a row on, it turns into a flipper that flips back and forth. So we can't have 3 bits in a row on. This is actually be a problem. So we actually use that to our advantage to determine if shellcode is actually valid for us. So import subprocess. So check output. So let's compile a file. B32, we're going to decompile the A file. So binary data is going to be our A file that we're generating. Actually, just data. So let's generate a long binary chain from, so calling ASM, compile an assembly file, output to A, disassemble it so you can see what it's actually looking like on the screen, see what the hex values are. Then we can generate a binary string and see if any 3 bits in a row are on to avoid any of the flippers back and forth. So range 0 data. If you use the bin command on, it removes number of zeros on you. So we can actually just do data I, and we don't want the, so bin actually does, will return a OB some number. It's not going to be 0 padded, and we don't want the OB portion. That's why I have the 2 colon. So then on bin data, we're going to add curve bin in the last 8 entries. So you get 0 padded and it's going to show. If we find 3 ones in a row, error about the assembly, else. We want to print out the assembly itself. Well, we also need it to be padded out to 110 bits. So bin data equals bin data plus 0 times 110 minus the length of the bin data. Print bin data, whoops, print bin data. And just to help us a little bit, 110. So let's first see if we actually call int 80. A.s. Problem with multiple different languages, there's multiple different ways to do comments. So we can call int 80. This is a good thing. However, having bits at the very beginning might cause trouble for us. So let's find an opcode that we can actually use that doesn't have very many bits turned on and actually helps us. If this will load back up. Sure. So we actually want, so if we can find something that's a couple of bits set together and is, say, a single opcode, hence me looking at the 1 by opcode map, but most of the bits are off, is actually useful. So starting off on to 0, 0, working over, all these are add. However, push ES is actually very useful. This is an 06. So we can actually do, just to confirm, so there is the push ES, and there's the int 80. So can I move EBX from ECX? That's not good for me. Oh, that's what I want. I could try exchanging, because exchange EAX with any register is actually only one opcode at a time. Maybe if I add some extra padding in here, that's acceptable. So then I could exchange EX with EBX, push ES. So now I'd have my EBX moved into the ECX itself. And then backwards. So EBX, ECX. So EX is now set. So move AL3. That's acceptable. And it's also small because move EAX is actually going to be larger. We know that EBX already got set 0 because EAX was 0. And that leaves EDX. Well, moving a large value to EDX is probably going to be a problem. Let's try it. We only need to get, if we can get the high register set though, or the high register of the low half, that is acceptable. Oh, that's invalid. Push yes. This is actually valid shellcode. So exchange EBX to EAX, exchange it into ECX. So now ECX is our pointer. AL would be 3. EBX is already going to be 0 from earlier. DH is going to be 1. So that makes the EDX be 100. This. We need to make this actually usable for sending out. So there's a couple different things that are useful in this still life. There's snakes, there's boxes, and there's tables. Tables are down here. Similar to this. The boxes are here. Snakes are this type of setup. Any of these can be rotated around too. So right here, this is if you roll for a snake. Or actually, however, that's going to cause a problem with this. Oh yeah, the other one is a diamond. The problem here is that this one has 3 entries, which means it's going to get turned on, and it's going to start mutating on us. Let's clear this out. Well, we can see that we can actually do a table here. If I rotate on its side. And I can do a box here. This 0, however, would have 1, 2, 3 entries, and that would get turned on. But if I put a box down here, it now has 4 entries, it won't get turned on and mutate on us. So I could do a box there, I can do a box here, I can do a table here. We learned that just as shown over here, we have to do another box next to the table because there's one next up here. This one looks like it could be a diamond because this is far enough away to not interfere. And we could do a box here. And this looks like we could probably do a snake. Another box. Another box. Another snake. Box. Diamond. Box. 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 Probably delete those. Now we have to actually send that over. So open up our file. Put on new line. So for x in 0 into bits. Whoops. Our y, because our y is going up and down. In range 0 into bits y. If bits y x is set, let's set send. Y and Python 3 likes everything being encoded. You read the actual data in too. My new process. Break at 56595,000 plus 1170 from earlier. let's see if I have the actual opcodes. Push, exchange. Something got mucked up. Push, move, push, move, push into 80. So we almost got there. Something got goofed here. First of all, push, exchange, push, exchange. I missed. Nope, that'd be right. I didn't get my one already typed there, so it screwed up this entry. Try again. It's not going to go well. Zero x 56568,000 1170. Continue. Center. Exchange EBX with EAX. Exchange ECX with EAX. Move AL3. 1 to DH. This display instructions as I execute them. So it's no reason to read a length of 1001, but our register is actually off in location. When we first did our first test, this was actually all 0. Now we're further into the buffer. Before we only set one location, and location is the very first entry on the buffer. So if that's true, let's try flipping our data around so we run XYs backwards. So do -1, go to -1, go reverse. -1, -1, -1. I don't put 0 here because I want to make sure it hits the very first entry. Although it shouldn't have anything there, I still want to make sure nothing gets screwed up. Don't mess up the parentheses. Right. 56,000 plus 70. Continue. Send input. So our EBX is actually smaller now. So read from standard in to our buffer, 1001 data. So this lets us call the syscall read and read straight into the buffer we're executing. So all we need to do is actually pad our buffer with however many bytes our actual payload is. So somewhere after d hex bytes, we can start putting actual payload data to keep executing when it comes back from the read call. A handy thing to always have around is shellcode. This is shellcode actually I've been using from when I joined Hates Irony years ago and has been floating around for years. It's very, very small and compact and works very well for most situations. I can't just send it straight over and have it work. I need to have it offset some. And I need to make sure I send enough bytes too. So this down here. So first of all, I need d bytes plus my payload. I then need to pad it out to 101 hex. Payload plus equal times 101 minus the length of payload. Now, the other thing we're not doing here is we actually have all of the data that comes back with for all the mutation or all the generations, and we don't really want to see those. So we can actually do a select statement to see if there's anything on the line. So select.select, my socket, no write, no error, half a second. 0 break. So if we hit the timeout, we won't get anything back in a return read. If our socket has any data that it read, it will get returned to us. Or the R value will be in a list, and in that list will be our S. So S is only when it goes in, so it's going to receive data off of it. Sleep is handling our timeouts, so I'm not going to worry about that here. I am, however, going to do, say, a 1 second pause right here, because when dealing with remote traffic, that can actually be a problem. So give it a moment to start processing and send data back to us. So we know that through debugging, we found a very small handful of instructions we can use. We verified the bits are valid. I've offset my payload for where it's going to receive the data into the same buffer and continue executing after the int 80, which should start executing my payload here. And I've had it for the amount of data that's going to be received, so the read call will actually return back. Because if read doesn't get all the data, it can be a problem. Select. Oh, let's try it. ls, I have shell. So where was the website? Back in the channel here. Challenge binary hex, yay. Cat flag. Who you generate life could be interesting. I actually went through the solve a little bit faster than I thought. When I did the solves a week or so ago, it actually was closer to an hour. I'm not sure where the time difference was. I will be on the channel for questions. I do plan to share the Python scripts I just wrote, and so everyone has access to what was done. I hope that people learned a lot from this. There's lots of little tips and tricks, even things like using pgrep to very quickly test things, or SOCAT for running and testing a binary locally, are things that not everyone is aware of and are easy tricks to become aware of as you play more CTF things. I hope you have been enjoying this. So have a good evening.
I was watching video lightning. I don't know if let's wait until I see what's going on. I was basically in shock. I think. You hearing me okay?
I can hear you fine.
Yeah. Okay. So, do you mind if we go right into short interview / questions?
Sure, that's fine.
It's fine. Are we still on Netflix?
Maybe.
Maybe.
So I think we're gonna be live. We just are going to wait a couple seconds so we see ourselves on the Twitch. There's a small delay, and I have a couple questions for you. I was told 2 seconds. Now it's 5 seconds. I really enjoyed the walkthrough. There's so many clever and things going on, and I was kind of expecting this to be done via solvers or stuff like that, you know. And it's actually a lot more like art, like craftsmanship. I feel like you built the little pieces as they were fitting, and the machine was helping you, doing so.
Yeah, a lot of people assume that it's a project for brute forcing or SMT solving, and it's not. It actually becomes a state space explosion issue when you try to actually do that. Because one single box is affected by 8 boxes around it. And this causes a major problem when you're trying to brute force solutions on that size of a scale. And that's 110 by 110 is quite small compared to some of the other very large setups I've seen in Conway's Game of Life.
No, but it totally makes sense, and those still patterns definitely help. But one thing that I only understood near the end of the explanation is that you built, maybe you said it, but language barrier and doing too much alt tab here, but the stager is just to read the rest of the shellcode that you don't need to encode in this fancy way, right? So
it's actually a very common trick in CTFs. A lot of CTFs, people assume you have to send the whole shellcode the first time through, and in reality, you just need to get a stager sent over. You still have a connection, so if you can just get a very, very small stager, it actually makes solving some prompts a lot easier. You're not having to deal with a large amount of data that you're trying to figure out.
To encode in a specific way or whatnot. Yeah. Do you find this to be working in like any like most situation, or is this specific to when you have a daemon that is basically a standard in, standard out type setup? Or does this apply to like most exploitation challenges?
It applies to any exploitation challenge that maintains a connection. So anything that drops off after you send the initial payload over, you have to send the whole payload because it needs to have everything it needs to do. But anything that maintains a connection, you already have your connection. Just read off the socket you're already connected on, or wherever your data is coming from, and keep on going.
A very good answer, and I'm glad it does make a lot of sense. Another thing that I wondered, I'm gonna stick to questions related on the challenge before I move on to other questions. Why did you do the select in order to do network I/O instead of just sending? I didn't get the specific reason.
So we know, so the challenge itself sends back all the generations. I think it's like 12 generations of data. However, with network traffic, especially when you're connecting remotely, you can't guarantee exactly how many packets data you're going to get. Sometimes the packets get combined, sometimes packets get broken up. So calling send or calling receive a fixed number of times may not guarantee the result that you expect. However, I knew that once it sent all that data over, it would not send anything more until I gave it the actual payload. So I simply said, keep receiving data until half a second passes. That's why I have the 0.5 or 0.5 on select. If half a second's passed and no more data has come through, then assume I'm at the end and send the payload to continue the process.
Yeah, sounds a lot simpler than the. So I have never been great at exploitation challenges, but I'm always struggling with this like receive line and receive for an amount of bytes and then sleep. But then I'm like, how come I don't have all of it? And I didn't know that Python actually exposed such a nice high-level interface to select, which for me was a low-level C system call. Or
yeah, it's very handy, and if there's data there, in my case, I was just calling receive and throwing it away. I could have called received and added it to a buffer. So I could have done select. If we're receiving, say, data and we're waiting for a new line, you can either call read and read one byte at a time, which is very slow. You could call select and say, oh, I have data, attempt to receive, say, 4K of data, and I only get a few bytes, but keep adding to a buffer and wait for wherever terminator is wanted to. So select is very handy.
Yeah, definitely. I really thought it was mostly a performance, do not sleep on I/O, do not starve CPUs on I/O type stuff, not as a also useful toolbox like that. So thanks for that tip. That's another thing.
You can receive and having it lock up on you.
You were saying you can have it lock up on you?
It keeps you from calling receive and having it lock up, waiting on data that never shows up.
Yeah, true. So I have usual questions that I ask challenge designers, because this is something that we like to learn more about the process and so on. And some questions bring other questions. And so if at any point there's a question you're not comfortable answering, let's say I ask for your employer or whatever, just say skip, and we will skip. I want this to be really respectful of everyone. And you can have your secrets. This is not about putting stuff on the internet that you don't want to be on the internet. So I like this first broad question, but how did you get started into playing CTF before designing?
So years ago, I joined a company called Raytheon that had a very large CTF group. At the portion of Raytheon I was at, I never played CTFs prior, and they asked if I wanted to come play CTFs one weekend. So it was a result of a new employer that I just started at, and they had a very, very large CTF group. That actually is where Hate's Irony came from.
Okay. And you fell in love with it, I guess?
I did. So I actually played CTFs for about 3 years. In fact, my first year, I also helped host Ghost in the Shellcode.
Okay.
After about 3 years, I actually had Legit BS ask me if I wanted to help them run, because they had someone stepping down that couldn't write challenges. And they knew the challenges I was creating for Ghost in the Shellcode, and asked if I wanted to help with challenges for their stuff. So prior was me doing both competition and creation of challenges.
So that's a very fast path into doing DefCon Quals and DefCon CTF main event challenges, I guess. 3 years, you're saying?
I was known for doing some very hard and insane challenges. In fact, every CTF team I've talked to, when they looked at my stuff, would call me insane. So considering that I was actually doing this type of stuff for Ghost in the Shell code and actually told to tone down the stuff I was doing for Ghost in the Shell code is too hard, it makes sense that they actually approached and asked me.
Yeah, definitely. No, that's interesting. Can you tease us with, let's say, your the one you're the most proud, or the hardest? I don't know if it's the same, but challenge you wrote.
DOS fun for you. If you look up the actual challenge is a DOS 16-bit protected mode binary. If you go past any of your buffers, you hit the end of memory and general protection falls to binary immediately. If you look at the actual solution online, where someone published a solution, A, the solution did not solve it the original intended way. B, it starts out with them having to patch IDA.
Okay, yeah, I see. You did have a solve in mind?
Say again?
You did have a solution in mind, like
In mind, the solution required filling up the memory. The way that you allocate memory had to be filled up and result in overlapping your memory with the DOS real mode memory areas. There was a bug in a linked list that allowed them to solve a different method, but still, I think we had 8 solves total. It had a flag in memory and a flag on the hard drive. And all 8 solutions got the flag out of memory and took another 4 hours to get the flag off the hard drive because the shellcode was so hard.
Wow. Thus for fun.
That's fun for you.
So you were saying, like, you started CTF as part of a previous employer or maybe current. How did it influence your career after that? Was it somehow related to you changing employers or not?
So the CTF work I did actually did influence my current career path. I'm not with that employer then. I'm actually at Microsoft now, and the security work I do now at Microsoft was directly influenced from the CTF.
Okay.
I actually had Microsoft approach me and ask me about doing security for Azure Sphere and handling security for their processor.
Oh. So kind of lower level, or is it hardware level, or?
So Azure Sphere is a chip for IoT devices running Linux and about 4 megabytes of memory. So I handle security from the firmware all the way through the system up to the point where it touches the cloud. So the full OS security, anything dealing with customer applications, CVEs, ways to better protect the system, all while dealing with only 4 megs of memory.
That's not a lot. I didn't thought Linux would fit in 4 megs of memory anymore.
It does.
Impressive. So I sticking to CTF questions, oriented questions. What is your workflow when you're trying to create a challenge? Like, basically, there's so many constraints, and some of them are like it needs to be solvable. So yeah. So how do you approach one? Does it start from an idea, or does it start from something different?
So all of my challenges have been a direct result of something I stumbled across that I found interesting, and how can I turn it into a challenge? Example, one of my challenges from way back during Ghost in the Shell code is called Bisexual. It actually alters between 32 and 64-bit code execution inside the same binary. And it jumps back and forth between them repeatedly. And all it's doing is it's actually mucking around with the current code segment that you're in for the x86 processor. Because Linux and Windows both set up memory pages in a way that they overlap for 64 and 32-bit to allow both to run. And as a result, if I just change out which the CS register itself and do a jump far to change that out, it can jump between 32 and 64. That's not something most people are aware of, and most people have never experienced.
Yeah, I was not aware of that.
Interesting. They made a whole challenge out of it.
I'm familiar with how ARM switches between thumb mode and normal mode, I guess. But I had no idea that something similar and using a different trick was possible on x86. And
that's
so,
the other thing I like about my challenges. I like exposing people to things that they had never come across before. A lot of challenges that people create are write some challenge and figure out some bug to put into it, or they read some paper and they base a challenge off some paper. I like to expose things to people that they've never pondered or thought about, but are always there in the hardware.
And do you maintain a list? Like while you work, you're like, wow, this is possible, and then you write it down somewhere, and then you come back to it, or?
I had a list. I will say that all the challenges I did for DefCon burned through 90% of my list. So that kind of
the list shrunk.
The list has shrunk, and the ways I was increasing that list are no longer available to me due to other work I was doing in the past.
I gotcha. Interesting, very interesting. Last question. Unless we have people that are willing to ask question, I should do a shout out actually. Just give me 1 sec. Any? But yeah. So last question. Maybe it's not that much of a good one. I just wrote it down a few minutes ago. But what was your first computer? Like, what got you into computing where it was clear that this was your main interest?
My very first computer was actually working on my mom's old 486. I think it was a 6 megahertz computer, or 50 megahertz is one or the other. My stepdad was a programmer at the time, and I just started being homeschooled. So I'd finish up homeschool at the time that he would wake up and start doing his job because he did work from home as a contractor. So I'd sit there for a good 8 hours before I went to bed watching him code and started from that.
And like right then it was like you had no interest in your normal games, playing outside or whatnot, or you still did, but it was not the focus.
And I found it far more interesting to be on the computer and figure out how things worked and why things worked the way they did. I mean, I was doing things like taking assembly apart and figuring out how various viruses worked and how boot sector functioned and how the processor functioned and digging deep into it. I had a book given to me for one of my birthdays for 3D game development on DOS. Flew through it in a month and then proceeded to call up the author asking more questions because the book didn't answer all the questions I had.
Wow. So, we chatted a few days earlier, and we realized that you've been doing computery stuff, and you just talked about DOS and so on before, but like back then there was no resources like there is right now. Like you had to have books, and you had to really try hard, and no Stack Overflow for stuff like that. And so seeing younger generation of hackers at work, or during your hobbies or in CTF, do you feel like they are spoiled, or do you feel like they are even better than us because of all these online resources? Or is there too much, right?
The whole computer field's actually blown up. So there's a lot more areas to poke at, a lot more areas to learn on. At the same time, a lot of the universities are not teaching the low-level stuff. They're teaching all the web development. They're teaching the cloud development. They're teaching things that do need to be secure and people do need to pay attention to. But it's a completely new arena that didn't exist back then. So it's not a matter of being spoiled. It's a matter of there's so many different arenas that you can now focus on and learn about that didn't even exist at the time. I mean, I was running around on bulletin boards and sending letters to Intel and AMD asking for books. Now you just go online and download the manual to get all the information you need. But the amount of extra information to go through and extra things to learn, it opens up whole new worlds.
Yeah, you could be rewriting the world in JavaScript instead of doing this right nowadays.
I mean, the virtual machine instructions on Intel now didn't exist back then. Those were a foreign concept, and now is in every processor and expected to exist. This is standard now. That's just one arena as an example of processor expansion in the same vein of processors that the 486 came from.
So much to look at. We have one question from the chat.
Sure.
If the person said that he she wants to learn more about a processor hardware vulnerability, where should they start if one wants to learn more?
Probably the easiest thing is go find various videos at Black Hat and DefCon talking about hardware vulnerabilities. I actually don't have a good book to recommend or a good exact resource to go after because of being self-taught. I know there's lots of videos out there of people doing hardware hacking. Those are probably places where I'd start to see what common threads are and what people are using for how they're doing stuff. If you find an area of attack that's interesting, example of timing attack, well, this gives you an area to start digging into to learn more about how does that work, why does it work, how to do it yourself, get hardware to then do it, example in Arduino, and start expanding.
And do you think attacking lesser common platforms is a good entry into that since they're simpler? Or should they focus on the big, because you mentioned Arduino, and I find this interesting. It's probably a lot easier to wrap your head around a simpler platform like that.
It's easier to start simple and then build up when you're still learning what the tools are and how the tools work. Once you know how they work and what's going on, then expanding and diving into something that's more complex and requires a lot more thorough process becomes easier.
Excellent, interesting also. Thanks for your time. I mean, I didn't progress much. I learned a few things for sure. Took some notes, and it's a very interesting challenge, and like it doesn't feel like a pure exploitation one, but rather kind of a puzzly exploitation, programming a little bit. So very fresh and interesting. Thanks for your time, taking the time to share with us. And sorry for the little time zone misunderstanding. I think this is one of a great monkey hack that we had, and this is all thanks to being online right now that we can have you on board. So thanks again.
You're welcome. I enjoyed it. I hope people learned something.
Oh, for sure. It's a matter of how much, one thing or many things or all the things. But yeah, I mean, this is kind of the DNA of our events, is that you're sure to learn at least one thing, right? It's if even the problem is way too hard for you, you can still, you'll have installed Ghidra, you'll have installed GDB, and the next time you try and a similar challenge, then at least you start with these tools installed, So we can try to have everyone at least learn one thing.
Yep. And I have other challenges, so maybe I'll pop up again with another challenge.
It would be good and appreciated. Thank you so much.
Thank you.
Have a great evening.
You too. Bye.
And with that, we are going to switch to games and shut the stream. So thanks everyone for your participation and presence. Thanks again, Lightning, for your presentation. It was amazing. And see you next month. For next month is going to be our Ho 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 Day special, where everyone brings a challenge and we play against each other's challenges. We're going to announce the detail relatively soon because the third Wednesday is coming up fairly shortly. And you need to provide challenges. So let's get started with that in the next week or so. See ya. And for the games, we're going to switch over to tables or Benelux Virtual voice chat.